Hello again, ladies and gentlemen. This is Mr. Smith, and this is 2.10 right triangles. All of this should be review. This is cycle 2. There are, of course, some things, especially in this lesson in particular, that will be new, but it's just an application of something you've already learned. So with that said, let's just get started. So we have finding a side of a right triangle. This should all come back to you pretty quickly. We have Pythagorean theorem, which if you learned that in grade 8, then you would have reviewed it in grade 9, and then of course we did it earlier this year. SOHCAHTOA, so that's your primary trig ratios. Sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. Now, if I'm going too fast through these notes, feel free to pause the video and copy it down. I am going to move along fairly quickly, just because this is review. Okay, moving on to our first example. In our first example here, we're given two separate measurements. We're given 2.9 and this value here, and our angle over here. We're given the opposite and the hypotenuse. So in SOHCAHTOA, we have O and H, so we're going to end up using sine. Sine of the angle that's given, not the 90 degrees, but the 49.9, will equal opposite over hypotenuse, like we wrote up here. Okay, so if I reveal this, should set it up like this. If you don't remember how to solve this, you put this over 1. So you put sine 49.9 over 1. If you do that, you can cross multiply, right? When you cross multiply, 1 times 2.9, then divided by sine of 49.9. You guys should be practiced in using your calculator. If not, pause the video now and give it a try. And you should get x is equal to 3.8, approximately. Of course, there is rounding. Our next example here, we have 2.3 and 3.4 given. No angles are given besides the 90 degrees. We do know it's a right angle triangle then. And we need to determine x. Well, in this case, we have no opposite or adjacent, but we do have a hypotenuse. Except we're going to use C, A, and B. Now, it doesn't really matter A and B. Those can get mixed up in this case, and the math will work out and we'll be fine. But C is important. C is always your hypotenuse. So when I reveal this, we're using our Pythagorean theorem. A squared plus B squared equals C squared. See how I mix them up? It would have been 2.3 squared plus x squared, which is the same as x squared plus 2.3 squared. So if you wrote this as A up here and B over here, it would be fine and work itself out. Now, you would normally just solve this the way you normally would with Pythagorean theorem. You'd square them, move numbers around, and then take the square root at the end. I am going to jump to the answer, x equals 2.5, because we have already done this quite a number of times. You guys should know how to do Pythagorean theorem by now. If not, just send me an email. We'll work through a few examples, and I'll make sure that you're ready to move on from there. Okay, third example. We are given two sides and an angle. So if this is the angle at the bottom here, 40.9, this means that this is the opposite and this is the adjacent because the hypotenuse is over here. Now we're not given the adjacent, so we're going to use O and A. If we look over back at SOHCAHTOA, O and A are here. That means we're going to use the tan portion. So tan of 40.9 equals our opposite, which is x, over A, which is 2.8. So you should set it up exactly like that. Then, if you recall, you put tan of 40.9 over 1 and cross multiply. So 2.8 times tan of 40.9 and then divided by 1. And you should get as x equals about 2.4. Of course, there's going to be rounding in this case because it says find x to 1 decimal place. Okay, that should be enough for the first example. The first slide. Let's move on to the next one. All right, this is the second half of the first page. We're going to find the angles now. Now, there's two different ways. The first way, I'm using Greek letters. Alpha, beta, and gamma add up to equal 180 degrees. Basically, just the three angles inside a triangle add up to 180 degrees. The other way is to use the trig inverse buttons. So you remember trig inverse, so instead of sine, it'd be sine inverse of some fraction, then cos inverse of some fraction, and tan inverse of some fraction to get to your final answer. And I'll write this out just to kind of show you. Just remember it looks like sine to the power of -1. That is different from sine inverse. These are just called the inverse trig. Okay, here in our first example of number 2, we are not given an angle, but we're given two side lengths. The side lengths that are given are opposite and adjacent. Our opposite's over here, adjacent's up here. I remember annoying you guys with that. If we take a look at SOHCAHTOA, well, if I write it out again, SOHCAH and TOA, just so I have it nearby, I see O and A goes with TOA. So that means I'm going to end up using tan. Now you sub in all the stuff that you know, and instead of using cross multiplication, you're going to end up using tan inverse. So this is actually going to be tan theta is equal to our opposite over our adjacent, which is 2.18, right? Then you're going to take the tan inverse of that. So you'll end up with tan inverse of your fraction, 1.52 over 2.18 is equal to theta. And you should get theta is equal to 35 degrees. Or in this case, x. I use theta because theta is usually what's used for the angle. So just bear with me on that. Let me rewrite it down here. Equals 35 degrees. And I'm going to fix this up here. Perfect. So that's how that looks. Our next example. We are given, well, this angle here. We're not given a number for this angle here, but because it's a box or a corner, a straight corner, we assume it's 90 degrees. So that means that we are actually given two of the three angles, and three angles of a triangle add up to 180 degrees. You should know this. If not, you can always go check back in your notes. So if we have 90 and 27, we need to figure out what x is, and in order to do that, we subtract 90 and 27 from x, or from 180, and we get x is equal to 63. Easy peasy. All right. Third and final example for finding the angle, we have two side lengths given. Well, we're given our hypotenuse, which is the one I like to label first, and then the opposite over here. So what uses O and H? Well, it's sine, of course. So we're actually going to use sine of x is equal to our 1.4 over 3.1. There we go. And then your next step, which I didn't type out, so I'm going to write it in here, would be to take sine inverse of that fraction. 1.4 over 3.1, because normally we would take the sine inverse of both sides, and then that would cancel out x, or the sine next to the x, because sine inverse of sine is just whatever the angle is, so in this case x, and then you do sine inverse of the fraction. So really it should be x equals sine inverse of 1.4 over 3.1. Okay. And if you punch that into your calculator, you should get x is equal to 27 degrees. All right. Let's move on to the first new thing. This has all been review. So the very first new thing, angle of elevation. Well, I just want to make sure I have my notes in front of me so I don't mess this up. Angle of elevation is the measure of an angle from up the horizontal. The angle of depression is the angle down from the horizontal. So what that means is, I'm going to use both these images here. We have angle of elevation, your line of sight, so the horizontal up. So you're measuring the angle horizontally up. Angle of depression, horizontally down. So elevation, you're feeling elevated, you're feeling good, you're looking up. Horizontal or angle of depression from the horizontal down. Depression, you're feeling down, you look down. So elevation, angle of elevation up, angle of depression down. So just think of it that way. I know it's a little bit tricky to memorize that. So hopefully that helps. Then we have bearings. So bearings will come into play a little bit more in calculus and vectors. I know that I use bearings a lot in that course. And if you choose to do something along the lines of engineering, this will come in handy then. So now that I've talked about that enough, north 30 degrees east. Sorry. You start facing north, then rotate 30 degrees east. Pretty straightforward. You're facing north, 30 degrees east. So you start with the first letter as it's written. Then you turn that many degrees in that last letter's direction. So south, 20 degrees west. So you're going to start facing south. Then you're going to rotate 20 degrees west. Okay. Now, if you're not given a number, it's supposed to be halfway between. Now, when we think of north, northeast, south, and west, they are 90 degrees in between each. So halfway between north and west would be 45 degrees. So halfway between, so north, 45 degrees west. So if you see just NW, that means 45 degrees in between them. Okay. Let me reveal this just to show you a diagram of what that looks like. Feel free to pause the video so that you can copy this down so that you have a visual representation of this. North, you start north, rotate 30 degrees. That's what that arc's there for, to show that I measured 30 degrees east. It is a little bit off scale because 30 degrees is an acute angle that's less than 45 degrees. So that would have been a bit more vertical. Same with the south, 20 degrees west. That would have been probably a bit closer to the S. However, we make do with what we can. It's just representing where we measured. Okay, I'm going to move on to the next slide now. All right. Excuse the awkward spacing for the question, but this was the only way I could get it to fit. So, for question 3, we have the angle of depression from the top of a cliff to a boat on the water is 25 degrees. If a boat is 360 meters from a cliff, how tall is the cliff to the nearest centimeter? So, nearest centimeter, okay, so there's a lot to take in here. Angle of depression, 25 degrees. The boat is 360 meters from the cliff. How tall is the cliff to the nearest centimeter? All right, let's start with a diagram and then figure out what this question's asking. Well, we know the unit's dealing with right angle triangles. However, we're looking at an angle of depression, and he's standing at the top of a cliff. So the angle of depression means he's looking down 25 degrees. So we're going to say 25 degrees down, and we're assuming the cliff is going straight up. We're just measuring how tall the cliff is, so it's just a straight line up and a straight horizontal line. to our boat, which I'll draw a happy little boat there. There we go. And we know the boat is 360 meters away. So 360 meters. Okay, nearest centimeter is the only thing that I'm missing really from here. I need to figure out how tall this is. And the nearest centimeter would mean 2 decimal places. Well, there's actually 2 different ways to go about this. Because there is a bit of a pattern here, you can determine what the angle of elevation from the boat up to the top of the cliff is. If you recognize it, that's going to make this much, well, it's not that hard of a question. It's going to make it easier, though, even easier than it already is. So what I would recommend is, if you know the Z pattern, you can work through it that way. If you guys remember the Z pattern. If you don't, that's not a big deal, because the horizontal is going to be a 90 degree here. So 25 plus whatever this is here is going to equal 90. So that means that this theta is equal to 90 minus 25. Now, 90 minus 25 is just equal to 65. And now we can use this angle. If you use the Z pattern, you're going to be doing math slightly different, but you should get the same answer. If you notice the Z pattern, I'll go over this in red to show you how to go about that. All right. So now that you have this 65 degree angle, you're going to do tan, because you have your opposite and your adjacent. So tan of 65 is equal to opposite 360 over x over your adjacent, because it's TOA. Put it over 1, cross multiply. 1 times 360 divided by tan of 65. And you should get x is equal to 167.5. Oh, 0.87 meters. There we go. Equals about. And if I double check by revealing my answer here, perfect. Awesome. Okay, I'm going to switch my pen color over to, say, red. Say we recognize the Z pattern and this was 25 degrees here and you worked your way through it. You could have done tan of 25 is equal to x over 360. Throw this over the 1, solve for x. You'd get the exact same answer. So then you'd go up to there. So there's more than one way to do this style of question. Is one way more right? No, not really. Either way is correct. You would get full marks for it. I just wanted to show you both ways. All right, I'm going to switch my pen back over to blue because I like blue. All right, next question, or next slide. This is our last example for this lesson. And this is a bit of a unique question. I've used this style of question many of times, and I like it because it actually has real-world applications of trigonometry. Because you take two angles and you're able to find the distance of something by using two angles and knowing one measurement. Anyway, let's continue on. Skippy is on top of a building that is 18 meters tall from another taller building. The angle of elevation from Skippy to the top of the taller building is 44 degrees. Well, let's underline that, underline that. Angle of elevation, so I know where that is. And the angle to the bottom is 53 degrees. Determine the height of the two buildings to the nearest tenth of a meter. So in order to do this, let's actually draw our connecting lines between these two buildings. There is two angles, an angle of elevation, which is 44 degrees, and an angle of depression, which is 53 degrees. And we know how far apart the buildings are. They're 18 meters. All right, it looks like we have two right-angled triangles here. And this would be a right-angled triangle down here. So now we just need to figure out the two values for, let's say this is x up here, and let's say this is y down here, x and y. And what we can do is we can set up tan, because the opposite is going to be x, and the adjacent is going to be 18. And this is going to work for both the top and bottom of the triangles to figure out x and y separately. So if we start with x, we have tan of 44 equals x over 18, because opposite over adjacent, cross multiply, and you get what x is equal to if you put tan 44 over 1. All right, same strategy for the next triangle. You have tan of 53 is equal to y over 18. Oops, went a little too far. So then you put that over 1, cross multiply, and you solve for y. So now you know the height of y. So you know y and x separately, and now we can add the two together to get the height of the taller building. So the height of the taller building is 41.27. The shorter building is going to be the height of y because it's directly across and down. So it's going to figure out how tall it is at level. So it's going to be 23.9 because that's what y is, rounded to the nearest tenth. And the taller building is going to be the two added together, rounded to the nearest tenth. All right, that should be enough for 2.10. Best of luck. If you have any questions, feel free to post them in the forum. And make sure to try the practice. And if you have any, I think that's everything actually.